Over the course of the 2010s, the LEGO Group produced notoriously brittle brown bricks. Certain colors of brick, including brown, dark red, and gold, would break under minor stresses such as that experienced when taking the bricks apart, an action that LEGO is designed for. Chemical reactions between the dyes of these bricks and the ABS plastic that comprises LEGO were to blame. LEGO remedied this issue by changing their dyes in 2019, but still a significant amount of brittle bricks are in circulation in the second-hand market. Brittleness can be quantified via stress-strain curves. Stress-strain curves of more brittle materials exhibit little plastic deformation before fracture. The area under these curves is lesser than that of ductile materials, as brittle materials absorb less energy before fracture. We suspect that a stress-strain curve of brittle brown bricks would exhibit these properties, as well as a lesser ultimate yield strength, that is, the maximum stress a material can endure before breaking. Brittle materials are not necessarily weaker than ductile materials. However, the ease at which brittle brown bricks break leads us to believe that they would be weaker than other, more ductile bricks. To construct our curves, we conducted tensile tests with the Mills Mark X mechanical tester. We tested 2 cm cut lengths of LEGO Technic axle pieces, as some lengths of axles were produced in brittle brown, the axles are of uniform density with no hollows, and the axles fit within the Mark X's clamps. A simple calculation of the maximum load that the axles may experience using the upper limit of ultimate tensile strengths of ABS plastic and the cross-sectional area of the axles indicated that load forces should not exceed 670 newtons. Therefore, the 2.5 kilonewton load sensor would be suitable for the tests.
We tested a consistent length of brittle brown axle as well as a light bluish gray axle, black axle, and the new non-brittle brown axle. For comparison, the mechanical tester measures the tensile load and the resulting displacement of the sample. We used MATLAB to interpolate the data to get stress versus strain plots and then graph that to a curve. Take note that light bluish gray is the strongest color, and this makes sense because many of the pieces that undergo a lot of stress and strain, such as the ball and joint bricks and Lego sets, are exclusively produced in light bluish and dark gray, so they're able to withstand these forces, and we find that very interesting. Also, let it be known that the small bump seen in the light bluish gray stress strain curve is possibly due to machine error, where the grips could have slipped and caused an error in the measurement. Our hypothesis is supported by our data. From the graphs, it can be observed that the brittle brown Lego has the lowest ultimate tensile strength compared to the other Legos. The other curves have ultimate tensile strengths greater by 20 to 40 units, and the ultimate tensile strength is the maximum stress that can be applied to the material before it fractures completely. The strain values of these graphs are also interesting. The black and brittle brown shared the same ductility, while the normal brown and light bluish gray had similar ductilities as well, 0.4 and 0.6 respectively. These lower ductilities also indicate differences in plastic deformation. The graphs of lower ductility had lower plastic deformation, and the graphs of higher ductility had higher plastic deformation, which can be seen in the area of the line that extends to the right. The coloring dye used in the version of the brown axle must have weakened the ABS plastic of the Lego. It could have done this by disturbing the van der Waals attractions between the polymer chains or the covalent bonds holding the main chains together, reducing the polymer's strength and ductility. We then conclude that the brittle brown is in fact more brittle than Lego pieces of the same shape and size but different color. It has the lowest ultimate tensile strength amongst the tested colors and shares the lowest ductility with black compared to the other colors. Thank you.